Section 4.7, Piecewise Functions, is the final section of Chapter 4. Seems like a marathon, Chapter 4. One vocabulary term, piecewise function. It's probably something you've never seen before, and that's okay. A piecewise function is a function defined by two or more equations, and there's going to be some limitations on when we use each of the functions in the piecewise function. So I've got an example here of what a piecewise function looks like. It starts with f of x, and then it's equals, and then this is like a squiggly little bracket. Now if you're looking at your computer, it's kind of the brackets are the buttons right next to the P to the right on the keyboard. And it's the shift and then those two buttons, the top ones of those two buttons. And then we got two different lines, x minus 2 if x is less than or equal to 0, and 2x plus 1 if x is greater than 0, okay? The graph of a piecewise function looks like this. We're going to do plenty of graphing, so you don't necessarily need to get this copied down exactly. But if you want to draw it, you certainly can. It might make sense, something else to refer to as you're doing your assignment. You know, we got two separate functions, 2x plus 1, that's a slope of 2, a y-intercept of 1, that's right here. It goes up 2, so we start at 1, go up 2, right 1, and there's our line. X minus 2 is a slope of 1, so that'd be up 1, right 1, but it's only if x is less than or equal to 0, so that's actually to the left. So that'd be down 1, left 1, and that's a closed circle because we have the or equal to part. I will explain all of this in greater detail here in a little bit. But let's first start by evaluating, okay? We can evaluate with piecewise functions, okay? Evaluate f of x from above, and I just wrote that same function right here, at the given value. So when x equals 0. Now the question becomes, and I'm going to write this, where does x fit in? Where does 0 fit, okay? 0, would it fit in this one, or would it fit in this one, the top one or the bottom one? Well, it says x is less than or equal to 0 on the top one, so we're going to use this one because x can be 0 for the top one. For the bottom one, it says x is greater than 0. 0 would not fit in the bottom one, so we have to use the top one, okay? So we're going to use the top equation, so we're going to say f of 0 is equal to 0 minus 2, which is just negative 2. We don't need to do anything else with, especially with the 2x plus 1, because x was not greater than 0. We don't even care about that. Since x was less than or equal to, and specifically equal to 0, we're going to use the top function. And so we're just going to plug in our x value for, or our number for the x value, and see what we get at the end. Okay, so then f of 0 is equal to negative 2. Let's try a couple more. When x equals 4, okay, this time 4, that is greater than 0, so we're going to use the bottom function. Okay, so it's going to be f of 4 is equal to 2 times my x value, which is 4, plus 1. So 2 times 4 is 8, plus 1, and then obviously 8 plus 1 is 9. So we can say that f of 4 is equal to 9. Let's try a third one here, negative 6. Okay, so negative 6, let me bring this function back in. So negative 6 is not greater than 0. Negative 6 is less than or equal to 0. So again, we're going to use the top function here. So I'll go back to red. So we're going to say f of negative 6 is equal to, so plug in x, or plug in our negative 6. So negative 6 minus 2. Negative 6 minus 2 is negative 8. So we can say that f of negative 6 is equal to negative 8. So when it comes to evaluating, we just need to figure out where the x value fits in our intervals. Okay, so if it's less than or equal to 0, if the number they're giving you is less than or equal to 0, then we use the top one. If x is greater than 0, then we use the bottom one. Are these intervals going to be the same every time? No, not at all. Okay, we could have x is less than or equal to 1 and x is greater than 1, or these inequality signs could be flipped, or the or equal to part could be on the bottom. It's really going to depend just on a case-by-case basis. But all you need to do is ask yourself this question: where does the x value fit? If it, whatever interval it fits in, that's the equation that you're going to use, or the function that you're going to use. And then you just plug it in and see what you get in the end. Okay, let's talk a little bit about graphing. Graphing can be a little confusing at the beginning. So I got 3 examples. I'm going to go through them slowly. Hopefully they make a little bit of sense. So graph the function, describe the domain and range. Let's focus on graphing the function first, okay? So I'm actually going to bring in some graph paper here. And we've got our function here, y equals, we got negative x minus 4 if x is less than 0, and then we've got x if x is greater than or equal to 0. So I'm going to draw my graph here, and that's going to be this, okay? Now I'm going to do the top line, the top function in red, and I'll do the bottom function in blue. Okay, let's start with the top function, negative x minus 4. This is in slope-intercept form, so that whole line, writing equations of lines, graphing equations of lines, all that still is appropriate, or it matters. Okay, so negative x minus 4 means we started our y-intercept of negative 4, and our slope would be negative 1. Okay, so we can say our slope is negative 1, our y-intercept is negative 4. Okay, so it equals negative 4. Okay, so a slope of negative 1 means we go down 1 and to the right 1, so we go down and to the right. We can keep going down and to the right, or instead of, whoops, I went one too far over, down and to the right. Instead of going down and to the right, I could also go up and to the left, 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 and we'll do a couple more here. Okay, so we've got our points. Now, I would recommend maybe using different colors for this. If you don't want to use different colors, that's totally your choice. I'm not going to draw the line yet because I'm going to show you or help figure out which is going to be open circles. Because remember in this graph up here, there's an open circle here, closed circle. Which side of the line do we draw? We're just going to get the points figured out first, and then we'll figure out the circles and the lines after that. Okay, so we've got the first one done, negative x minus 4. The second one, the slope, the number in front of x, is positive 1. The b, there isn't 1, so we can say that the y-intercept is 0. Okay, so we'll start at 0, and then a slope of 1 means we go up 1 and to the right 1, up 1 and to the right 1, up 1 and to the right 1, up and to the right, up and to the right, up and to the right. Or instead of up and to the right, we can go down and to the left, down and to the left, down and left, down and left, down and left, down and left. Okay, and there's that last point. Okay, so we have our two lines. Now the question becomes, well, what lines do we draw, what circles do we make, and we go from there. Okay, so let's go back to the red one. I'm working on the red one here, this one. Okay, so it says if x is less than 0. Now if we think about our linear inequalities, if I was saying x is less than 0, if I did negative 1, 0, and 1, that would be a closed circle with an arrow to the left. Well, we can think about it the same way with these lines. Okay, so we find our x value of 0. That'd be right here. And since it doesn't have the or equal to part, we can make an open circle around this. Okay. Now, the less than points to the left, so we're going to go to the left this way, and then specifically this way with our line, with our shading. So we're going to draw in our line this way. Okay, so that's going to be how we draw in the line for the red one. We can do the same thing for the blue one. So now our x value is still 0. Okay, so that's this point right here. We have an or equal to part, so that means we're going to have a closed circle. I'm just going to make that a little bigger. And now it says x is greater than. Greater than is to the right, this way. So we're going to go to the right following these points. So we'll draw in this line, and we can put our arrow on the end of it. Okay, the rest of these extra points that we drew, if you want to erase them, you can. It's not the end of the world if you don't. It looks nicer if you do, but I'm not really concerned about prettiness at this point. We're just kind of figuring out the basics of graphing piecewise functions. Okay, so now we've graphed our function. Now we need to identify our domain and range. I'm actually going to erase this because we don't need it anymore. And it just might be extra work that it might be a little confusing. So let's talk domain. Domain is the x value, all the x values. If we talk about all the x values that are less than 0, and then this one talks about all that are greater than 0, including 0, we've covered all of them. Okay, so the domain for this piecewise function, and actually most piecewise functions, the domain is going to be all real numbers. Okay, we've used every x value. It goes forever to the right, goes forever to the left. The overlap does not. We got an open circle here, but a closed circle here, so we are using every x value. Okay, the range, draw that. The range are the y values. Okay, so we've got the lowest point looks like this point right here, negative 4, and we're going up and we're going up. Okay, so the lowest point we're ever going to have is negative 4, but we have an open circle here at negative 4, which means we can't use negative 4, the y value of negative 4. Okay, so we can say that the range is going to be all y's greater than negative 4. We don't want to include negative 4. It's not going to be or equal to. Okay, I'm going to erase that. Okay, it's not going to be or equal to because we have an open circle here. If this was an open circle, then this would be greater than or equal to. But since we have an open circle, we can't use that y value of negative 4, so we have to say y is greater than negative 4. Okay, let's try another one. Number 2, y equals x plus 1 if x is less than or equal to 0, and negative x if x is greater than 0. So I've got my x and y axis drawn in. Let's do what we did in the last one. I'm going to do the first equation, or the first function, in red. I'll do the second one in blue. So let's go ahead and try this. So we've got x plus 1, so that means our slope, again, is 1. Our y-intercept this time is 1 as well. So we're going to start at 1, and then we're going to go up 1 and to the right 1. A slope of positive means up and to the right, up and to the right, up and to the right, up and right, up and right, up and right. Instead of up and to the right, we could also go down and left, 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 down and left. Okay? So we've got our first line. Now we'll do the same thing with the blue one. Our slope here is going to be -1, and our y-intercept, since there's not plus anything, that's going to be plus 0. So we're going to start at the origin at 0, 0. And our slope is -1, so that's going to be down 1 and to the right 1. And we're going to continue that pattern for a few dots. And we'll also go up and to the left, go the opposite direction, so we have lots of points in case we need to go in either direction. Okay? So let's go back to the red one. We've got our points drawn. Now let's go back to the red one. We say x is less than or equal to 0. So the x value we're concerned with is 0, this one right here. And then since I've got or equal to, less than or equal to, I'm going to make this a closed circle. I'm just going to make it a little bigger. And then it says x is less than. So less than is to the left. And the left part is down here. So I'm going to cover up these points right here. And this is going to be the red part of the piecewise function. Now we're going to do the same thing with the blue one. Okay, so I've got x is greater than 0. So we're looking at the x value of 0 again. So we got this point right here. There's no or equal to, so this needs to be an open circle. And this says greater than 0, so greater than is to the right, this way. Greater than is this way. So we're going to follow the line. So it's going to be down and to the right. So it's going to be right here. Not the greatest of lines, but it works. Okay, so there's our picture. Now let's talk about domain and range. Domain, range. Okay, the domain, the x values. This says less than or equal to 0. This says greater than 0. I don't think there's any number that isn't covered. Every number is either smaller than or equal to or bigger than 0. So our domain is all real numbers once again. The range, this time both arrows are going downward. The peak point right here is a y value of 1, and we can use 1 this time because it is a closed circle. Okay, so everything +1 and smaller get covered by the function. So we're going to say y is less than or equal to +1 for our range. And that would be your final answer then for example number 2. Let's try a third one here. Y equals x minus 2, and if x is less than 0, and 4x if x is greater than or equal to 0. Once again, I'm going to bring in graph paper, bring in my x and y axis, and let's go ahead and graph. I'm going to do the top one in red, the bottom one in blue. So the top one in red, the slope appears to be 1 again. The y-intercept is -2. For the blue one, the slope is 4. The number in front of x is 4. The y-intercept doesn't appear to be 1 written, so we're going to assume that it's 0. So let's go ahead and put these points on the graph. So our red one, we start at -2 on the y-axis, and then we go up 1 and right 1 for our slope of 1, up and to the right, up and to the right, up and to the right, up and to the right. Or instead of up and right, we can go down and left. We should go both directions just in case, depending on which way we need to make our arrow. Do the same thing with the blue one. Start at your y-intercept of 0, so the origin. Slope of 4 means up 4 and to the right 1, so that's going to be there. I don't have any more room. I mean, I could make another one up here, I guess. Down and to the left would be here, and then down and to the left, I'll slide this just a little bit. Down and to the left would be over there. Okay, so I got my points for the red and the blue. So go back to the red. It says x is less than 0. So the x value we're looking at is 0. It says x is less than. There's no or equal to, so this is going to be an open circle here. And it says x is less than, so less than is to the left, this way. And we need to follow the line, so that's down that direction. So there is our red line. Now do the same thing for the blue. The blue says greater than or equal to 0, so this value right here, this middle one, that's going to be our closed circle this time because it is or equal to. And then it says greater than is to the right. So the right-hand side of the line is up here. So we're going to go this direction with our line. Now, do we want to erase? We can. We can erase these extra points if we wanted to. Makes it look a little nicer. Not the end of the world if we don't do it, though. The domain here. Domain. Well, it looks like we got less than 0, greater than, or equal to 0. That's all of them. So the domain here, all real numbers. The range. This one's a little different because we got arrows going in different directions, but the arrows do not overlap. Okay, so it's not like the red one starts over here and goes downward. Okay, they're right on top of each other, but there's this gap here between -2 and 0. So we actually are going to write two statements for the range. For the blue one, we can say that the range is y is greater than or equal to 0. Okay, so we look at the bottom point and it's going up. The bottom point is at 0 and includes 0 because we have that or equal to part. Okay, so it's going to be greater than or equal to 0 because that's the blue one. For the red one, we're going downward. Whoops. We're going downward starting at -2, but we do not get to include -2 because that's an open circle. Okay, so it's going to be y is less than -2. So the range is a little different for this one. If you've got arrows that don't overlap, that are pointing in different directions, you might have to write two different inequality statements for the range, and that's totally okay. All right, the last thing in the section, writing graphs. So I give you the function, you give me the graph. That's what we did in the first three examples. Now we're going to go the other direction. I'm going to give you the graph and you give me the function. So how I do this, I just break this into separate parts. Okay, so let's start with the left arrow. That's this one here in red. It appears that our slope and our y-intercept are what we need to figure out. So the y-intercept is going to be pretty easy. Okay, it looks like that appears to be -1. Now the slope, it looks like I go up 1 into the left one, so that would be +1 over -1, +1 over -1, +1 over -1. I would say our slope here is -1. Okay, so then we can say that would be y equals -1x minus 1. Okay, that would be our equation for the left. Now for the right, we'll do that one in blue. For the right, okay, so it appears we need to know the slope, the y-intercept. The y-intercept, forget the open circle for now. That'll come and we'll deal with that in a little bit. That appears like it would be +2. Okay, so we can say our y-intercept is 2. The slope looks like we're going up 1 into the right one, up 1 into the right one, up 1 into the right one, up 1 to the right one. So if we go up and to the right, that's a positive slope, and 1 over 1 is 1. So then we can say y equals 1x plus 2. Okay, so now let's see if we can't write out this function. So we'll do this in purple. So we can say y equals, we need our squiggly bracket, leave room for 2, because we've got two pieces to this function. The first one, we can do that in red, -x minus 1. The second one is blue, so that would be x plus 2. You don't need to write the y equals twice, just once. Okay, then we need the lovely words if on both sides, or on both of them. And then we need to figure out that last part where we've got x, that inequality part where x is greater than or equal to, or less than or equal to, or greater than or less than. We need to figure out what those inequalities are going to be. Okay, for the left one, it appears that we are allowed to use the closed circle at the x value of 0, and we're going to the left. Okay, left is always less than, and then that x value here is 0. So we can say that y is equal to -x minus 1 if x is less than or equal to 0. Okay, that's going to be our inequality for the red one. Now for the blue one, our x value is still 0. Okay, so we'll put whoops, let me go back to the pen. 0 is going to go there, and this time we're going to the right. Okay, so to the right is always greater than. Now the question becomes, do I need or equal to? Well, this is an open circle. And if it's an open circle, that means you don't get to use the or equal to. So it's just going to be x is greater than 0. You're never going to have more than one or equal to at the same x value. Okay? You might have more than one or equal to part in your function, but it's not going to be at the same x value. And I've got an example of that here in just one second. Okay, so this line, these two lines right here, this is our final answer. Y equals -x minus 1 if x is less than 0, and x plus 2 if x is greater than 0. That would be our piecewise function for the graph there for number 1. All right, let's try one that's a little more complicated. This one has 3 pieces to it. Okay, but again, even though it's got 3 pieces, it doesn't really matter. We're just going to continue to do the same thing that we've done. Okay, so we'll start with the left. So that's going to be this one. We need to know the slope. We need to know the y-intercept. So the slope, let's see. We go up 1, left 1, up 1, left 1, up 1, left 1. So I would say our slope here again is -1. It's going up and to the left, so that's a negative slope, or down and to the right, so that's a negative, and then it's up 1, right 1, so that's a slope of -1. Now, This doesn't cross the y-axis, so we don't know what the y-intercept is just by looking at it. But what we can do, we can continue to extend this line. We can go down one, left one, down one, left one. What we're going to find is that we would cross the y-axis at -2. Okay, so then we could say y is equal to -x minus 2 for the left one. Now, for the right one, let's do that one in blue still, keep our same colors. The right one, still need to know the slope, still need to know the y-intercept. We're going to have to do the same thing as far as finding the y-intercept. We'll come back to that here in just 1 second. Okay, but let's figure out the slope first. This looks like I'm going down 2 and left 1. So negative and negative make a positive. I'm going up and to the right for the general shape of the line, up and to the right. So that is a positive slope, and that looks like it's up 2, right 1, up 2, right 1, up 2, right 1. So I would say our slope is 2 over 1, which is just, 2. The y-intercept, again, keep doing the slope, down to left 1. Looks like we would cross right there, which is the y value of -3, or on -3 on the y-axis. So then our equation, y equals 2x minus 3. Okay? Now we need to do the middle one. So I'll do the middle one in green. So middle. We need to know two things. We need to know the slope, we need to know the y-intercept. So the slope, this is a horizontal line. The horizontal line always has a slope of 0. Okay, and then the question becomes, where does it cross the y-axis? This time we can actually tell that. Looks like it crosses the y-axis at 2. Okay, so our equation, y equals 0x plus 2, and 0 times x is really just 0, so all you need to do is write the number where it crosses the y-axis, y equals 2. Okay, so let's go ahead and write our piecewise function for this. So I got y equals, I'm going to need 3 lines this time because we got 3 pieces to this. I'll do the left one first, so we had -x minus 2. The middle one, well, I'll do the next one, that'll be just 2. And then the right one on the end, that was 2x minus 3. Then we need the word if 3 times, if, and if. And then we'll need to figure out our inequalities. Let's start with the left one. Okay, the x value where the circle happens is -2. Okay, so this time it's not going to be 0, and that's okay. Sometimes it won't be. -2 is our x value, and it's close, so that's going to be an or equal to part, and it's going to the left. Okay, so it's a closed circle at -2 going to the left, which means our inequality is going to say x is less than or equal to -2. Okay, that's our inequality for the left one. Now I'm going to skip the middle one, and we're going to go right to the right one. Okay, the x value where our circle happens is 1. Okay, and again, it's closed, so that's going to be an or equal to part. This one is going out to the right. Okay, since this one's going to the right, that's greater than, and since we have a closed circle, that's greater than or equal to. So x greater than or equal to the x value where that circle happens is, whoops, that was supposed to be the arrow. This point is an x value of 1. So this is going to be x is greater than or equal to 1. Now the middle one, this one's a little tricky because we're in between 2 numbers. So if we're in between 2 numbers, then we can use a compound inequality. Okay, this is going to be one where we use the small less than x less than big. And since we have open circles at both of our inequality symbols are going to be strictly less than. Okay. So then the smaller of the 2 x values is right here. That would be an x value of -2. So we're going to say -2 is less than x, which is less than. Now the biggest one, the bigger x value is right here. That would be an x value of 1. Okay, so we can say that that y is equal to just 2 if x is between -2 and 1. So this is an example I said earlier that you're not going to have more than, you could have more than one or equal to part in your piecewise function, and that's very possible. I've got one right here. But what the key is you're not going to have the same number with an or equal to twice. Okay, so you're never going to have, like, we've got -2 twice, but we don't have or equal to on both of them. It's only going to be on one of them. Okay, and that's where the open and closed circles come in handy. That tells you which one is which.